Imagine for a moment a really complex problem, something that feels almost, well, impossible to crack. Maybe it's one of those super rare medical diagnoses, where the symptoms are all over the place, maybe overlapping. Sometimes they even seem to contradict each other.
Right. Ambiguous signals.
Yeah.
Very tricky.
Or maybe think about a really nuanced legal case. Layers of precedent, maybe conflicting rulings, and there's just no single easy answer.
Yeah, the kind of stuff where context is absolutely everything.
Exactly. And we often hear people say, oh, AI can't really handle that. Why? Because the data's incomplete, or it's messy, it's sparse. That's the common idea, isn't it?
It is. That's the narrative we often get.
But then you stop and think, wait a minute. Human experts, doctors, lawyers, engineers, they deal with this kind of murky stuff all the time, right?
They do. They navigate that uncertainty constantly.
They do top-level critical work even when the information isn't perfect. So what's the real difference there? What do human experts have that AI, even with all its power and data, hasn't quite nailed in these tricky spots?
That's a really crucial observation, and it points straight to a fundamental question. If it's not just about missing data, what is stopping AI from, performing at those highest professional levels?
Right. What's the core thing?
Well, our sources, they suggest it's something much deeper than just data volume. It boils down to critical thinking, real logic, sophisticated reasoning.
Okay, so thinking, not just pattern matching.
Exactly. Think about that medical case you mentioned. A patient comes in, maybe a few weird symptoms, nothing fits neatly, some test results are ambiguous.
Yeah.
A good human doctor doesn't just run down a checklist. They connect dots that seem unrelated. They infer possibilities from really weak signals. They think about rare conditions.
They consider the whole picture, the patient's life.
Precisely. They build a coherent story from fragments. And this isn't necessarily about feeding the AI more raw data. It's about improving its fundamental ability to think like that expert.
To make those leaps.
To make those inferential leaps, yeah. To build logical arguments you can actually follow, even from limited, fuzzy information. Current big AI models, the generalist ones.
Yeah, the ones we hear about all the time.
They're amazing at language, sure, they can pull up facts, but they often really stumble on this kind of deep, multi-step logical deduction.
Why is that? Is it how they're built?
Largely, yes. They're primarily designed for finding statistical correlations in absolutely massive data sets. They're not really built from the ground up for constructing an argument from first principles or handling that kind of ambiguity rigorously.
Oh, okay.
So that is the real frontier right now. Teaching AI to reason effectively, to perform critical thinking that's on par with, maybe even better than, human experts in these really complex, murky water situations.
That really clarifies the challenges, not just the what the information, but the how. How the AI processes, understands, reasons with it, especially when things are fuzzy.
Exactly.
That's right.
The how is key.
And this brings us right into, well, a really fascinating and honestly a pretty practical shift that seems to be happening in AI right now. For years, the big dream, the sort of Mount Everest, was artificial general intelligence, AGI, right?
The ultimate goal for many.
This single super smart AI that could, theoretically do anything a human could do, probably better.
A powerful but maybe distant vision.
But what if chasing that one giant monolithic dream isn't the most effective way forward, especially right now, given how much resource it takes and how hard true reasoning seems to be to crack at that scale?
It's a fair question. The hurdles are immense.
So instead, what we're seeing is this really interesting pivot towards something more, tangible, more immediate, and frankly, incredibly powerful for real-world progress today.
Something we can actually build and use now.
No. Artificial Narrow Domain Superintelligence, NDSI. That's the focus of this deep dive. We're going to explore how two really groundbreaking approaches, one coming out of Princeton University, the other from a company called Sapient.
Two distinct but potentially synergistic efforts.
Exactly. How these approaches are not just making this NDSI vision more doable, but also way more useful for tackling critical challenges right now. You're going to discover how specialized AI, smart little experts working together, might just be the key to unlocking AI's real potential for complex thinking without needing planet-sized computers.
It really is about practical, impactful AI, solving actual problems now, not just aiming for some far-off, abstract intelligence. That's the exciting part.
Okay, so let's dig into this transformation. Moving from the giant generalists to these hyper-focused specialists.
Yeah, let's unpack that shift.
For ages, it felt like the main story, the buzz, was all about building bigger and bigger generalist models.
Scale was king. More parameters, more data.
The thinking was basically if you just keep feeding these huge models more data, more compute power, eventually somehow breakthrough reasoning would just emerge.
Sort of like intelligence through sheer volume. It was a dominant idea.
And we've definitely seen and still see enormous investments going into these colossal models, always pushing the scale.
Billions of parameters, terabytes of data. The numbers are staggering.
But while these generalist models are amazing at some things, like writing text or knowing a lot of facts,
They are undeniably impressive in those areas, yeah.
There seems to be this growing recognition, maybe a kind of countercurrent emerging, that just making them bigger isn't necessarily making them better at deep reasoning.
Exactly. There are diminishing returns, especially when it comes to complex multi-step logic. And that's what's truly fascinating now, this clear, deliberate shift in some of the leading-edge AI research.
So what's the new focus then?
The new paradigm isn't really about building the next behemoth model that tries to do everything. It's more about developing these highly specialized AIs, models that achieve genuine, verifiable mastery, but within very specific individual domains.
Like an AI that's only an expert in, say, protein folding or contract law.
Precisely. Think of it maybe as moving away from trying to build one AI that's like a broadly knowledgeable jack of all trades.
A polymath AI.
Yeah, a polymath, but maybe a bit shallow in complex reasoning. And moving towards creating a whole network of brilliant, really focused specialists, each one a true super expert in its own little area.
So it's not just philosophy driving this. It's driven by actual limitations of the bigger is better idea. What are those limits pushing this specialization?
Oh, absolutely. It's very practical. These huge generalist models, while great at recall and fluency, often hit a wall with the kind of symbolic step-by-step logical reasoning that human experts use all the time.
Okay.
Then there's the cost. Just training and running these things is astronomically expensive. Massive data centers, huge energy consumption.
Right, the practical barriers.
And interpreting their decisions, trying to figure out why they made a certain prediction. It can be incredibly difficult with these giant black boxes. That's a huge problem for using them in critical areas like medicine or finance, where you need explainability.
You need to know how it got the answer.
You absolutely do. But maybe more fundamentally, even with all their size, they can still struggle with that deep multi-step logical deduction. They can state facts, sure, but can they reliably deduce something truly novel from a unique situation?
Can they build an argument?
Can they build a coherent, explainable argument from first principles within a very specific field? Like diagnosing that complex disease from just a few symptoms. That's where specialization really shines.
Okay, so why specialize then? What's the core advantage?
Because these expert systems, by really deeply mastering their niche, using carefully selected high-quality knowledge, they can then work together, collaborate effectively.
Ah, like a team of human experts.
Exactly like that. Imagine a complex medical case. You don't rely on one doctor who knows a little bit about everything. You bring in the specialist surgeon, the oncologist, the geneticist.
Each bringing deep knowledge.
Deep, specific knowledge. No single person can master it all. And that's the model for ANDSI. You bring together these focused AI intelligences, combine their unique strengths, and solve problems that are just too complex, too nuanced for any single generalist AI to handle well, or maybe even at all.
Depth over breadth.
Depth over breadth, exactly. Yeah. Creating a kind of collective intelligence that's much more capable, much more robust. And frankly, this approach makes achieving AI superintelligence feel much more, doable and useful now, not just in some far-off future.
That comparison, the polymath versus the network of specialists that really clicks, it makes so much sense for tackling messy real-world problems. So, okay, let's get into the specifics. Let's start with Princeton University. Their contribution is this bottom-up knowledge graph approach.
Right.
Now, that sounds maybe a little technical, a bit academic, perhaps.
It can sound that way initially, yeah.
But this is where it gets really interesting, I think. It's about building intelligence from the ground up, but with like an inherent structure built in, not just throwing data at the wall and seeing what sticks.
That's a great way to put it. It's like building a house with a proper blueprint versus just, randomly stacking bricks and hoping it stands up.
Okay, I like that. So knowledge graphs, connect that to the bigger picture for us. What are they really?
So think of knowledge graphs as these highly structured interpretable frameworks for organizing information. They're not just databases. They're like vast interconnected networks.
Networks of what?
Networks where entities like specific genes or drug compounds or disease pathways or legal precedents are the nodes, the points in the network.
Okay.
And the crucial part is the relationships between them. These are the connections, the edges, things like gene A activates pathway B, or drug C inhibits gene D, or precedent X applies to case Y under condition Z.
So it's not just that they're connected, but how they're connected.
Exactly. The how is defined with precise meaning, semantics. The AI understands the nature of the link. So instead of just feeding an AI tons of raw text, hoping it somehow figures out these complex dependencies through statistics,
Which sounds prone to error.
it can be very noisy. Princeton's method uses these clean knowledge graphs to create what they call domain-specific curricula.
Curricula, like for school.
Almost, yeah. It means the AI learns from meticulously curated foundational truths within its specialty. It sees the explicit logical connections, not just correlations buried in messy internet data.
So it's learning from a clean, structured source.
Precisely. And this fundamentally improves its logic and reasoning because it has this clear semantic backbone to work from. It supports that critical thinking we were talking about.
Okay, so this domain-specific curriculum, does that mean the AI is almost like following a structured textbook, getting guided study instead of just, reading every single medical paper ever published and trying to sort it out itself?
That's a really good analogy. It's much closer to an expert-designed curriculum than just being thrown into the deep end of a giant library.
Makes sense.
Imagine trying to become a surgeon just by reading every medical journal out there, randomly. No courses, no labs, no structure, you'd drown.
Totally overwhelming.
Princeton's approach makes sure the AI, and they mention one model, QWQ Med 3.
Right, QWQ Med 3.
It's not just consuming raw stuff, it's learning from a carefully built, logically sound picture of its specific world.
So this leads to the obvious question then. How can a smaller model, like this QWQ Med 3, possibly outperform those giant generalist models? Doesn't conventional wisdom say bigger is better?
It does, but this challenges that. The key difference, as you hinted, is precision.
Right.
Quality over just raw quantity.
Okay.
By fine-tuning these models on very specific, very clean symbolic knowledge that comes directly from those reliable knowledge graphs.
Instead of noisy web data.
Exactly. Instead of broad, noisy data sets full of irrelevant stuff, contradictions, maybe even flat-out errors, these models become incredibly good at what the source calls expert problem solving, but only within their specific niche.
Laser-focused expertise.
Think of it like training a specialist surgeon. You give them the most precise, relevant medical knowledge, the best techniques for their area. You don't just hand them every book in a general library and say, good luck finding what you need.
Right. That makes sense.
That focus, powered by clean, structured data, is what lets them achieve that narrow domain superintelligence. They can make deeper, more reliable inferences than models just learning statistical patterns from huge, messy data sets.
That distinction, quality versus quantity, and how the data is structured, it really does feel like a different way of building AI, a more deliberate way.
It's definitely a Shunden philosophy, yeah.
Okay, now let's bring in the other piece of the puzzle, Sapient. Their contribution takes a totally different angle, but it seems like it complements the Princeton approach perfectly.
It really does seem synergistic.
They have this new hierarchical reasoning model, HRM. And this thing apparently just throws the whole bigger is better idea out the window when it comes to reasoning.
It's genuinely counterintuitive based on what we've seen with large language models, yes. What's really stunning about HRM is its efficiency. It's almost hard to believe.
How efficient are we talking?
Well, the source says it gets near perfect accuracy on really demanding reasoning tasks, with only 27 million parameters.
27 million. Compared to, what are the big ones now? Billions. Trillions.
Hundreds of billion, even trillions for the absolute largest. So 27 million is tiny in comparison.
Wow, yeah. What else?
Get this, it requires no pre-training.
No pre-training, that massive step that takes huge amounts of data and compute.
Gone, which saves enormous amounts of time, energy, cost, you name it. And it apparently uses minimal training examples.
So small model, no pre-training, needs very little data. This sounds radically different.
It's a complete contrast to the usual gigabytes, terabytes, massive parameter counts we associate with high-end AI. It really shows that smart reasoning doesn't have to be computationally extravagant.
Which makes it way more practical for the real world, right? Closer to that ANDSI goal.
Absolutely. It opens up possibilities for deployment where resources are tight. It's a fundamental rethink of how you achieve complex logic efficiently.
Okay, my immediate reaction is, how? What's the secret sauce here? How does Sapient's HRM pull this off? The source mentioned something about a brain-inspired dual timescale architecture.
That's the core insight, yeah. Its design cleverly mimics how our own brains seem to tackle complex problems. It separates two kinds of thinking.
Okay.
There's the slow, abstract planning. That's like, mapping out a whole strategy, thinking about long-term consequences, seeing the big picture from scattered clues.
High-level thinking?
Right, and then it separates that from the fast, reactive computations. These are the quick, almost intuitive responses you need in the moment. Executing one step of the plan, reacting instantly to something new.
Okay, give me an analogy.
Think about planning a long road trip. First, you figure out the route, the stops, the overall journey. That's the slow, abstract planning.
Got it.
Then, when you're actually driving, you're making constant, rapid decisions, steering, braking, checking mirrors. Those are the fast, reactive computations based on the immediate situation, but guided by the overall plan.
Ah, okay, so HRM does both.
It does both, efficiently switching between them. This allows for what the source calls efficient dynamic reasoning in a single pass, unlike older models that might just chug through information linearly.
Getting bogged down.
Right. HRM can be more agile, using the right kind of computation for the right part of the problem. It makes it incredibly nimble for complex logic puzzles. It's more energy efficient, maybe more biologically plausible too. It really paves the way for specialized AI that's both smart and practical.
So it's not just theoretical. We need proof. To give listeners a real feel for what this HRM can do, abstract planning sounds great, but what can it actually solve?
Good point. The source gives concrete examples.
Like what?
It says HRM achieved near-perfect accuracy on things like extreme Sudoku and large mazes.
Okay, Sudoku and mazes, are those just like fun puzzles, or do they represent something more?
They're definitely more than just parlor tricks. Extreme Sudoku requires really intricate logical deduction. You need constraint satisfaction, multi-step planning ahead.
You can't just guess.
Absolutely not.
Yeah.
And navigating large, complex mazes, that demands serious spatial reasoning, planning optimal paths. These tasks really test deep strategic thinking and efficient problem solving.
So they're proxies for real logical challenges.
Exactly. They demonstrate a robust ability for critical thinking. It's not memory, it's not just statistics, it's genuine inference. Understanding rules, applying them, anticipating consequences, finding the best solution in a complex, structured space.
The kind of skills we said AI needs for expert-level work.
Precisely those skills. HRM's success on these kinds of problems really validates its whole approach to building reasoning capabilities efficiently.
Okay, this is where it gets really exciting for me. We have these two separate, powerful ideas. Princeton, building these clean, structured, interpretable knowledge bases like that perfect library.
The foundation of curated expertise.
And then Sapient's HRM, this super efficient, agile, brain-like reasoning engine. It can plan, it can react, it understands logic deeply, like a brilliant mind ready to use that library. Now, imagine putting them together, merging them. What happens then?
That's where the real magic, the synergy could happen. If you connect this to the bigger picture, putting them together creates this incredibly powerful new framework. You could potentially ramp up the logic, the reasoning, the critical thinking of AI models dramatically, but without the usual massive costs.
Well, so?
Well, HRM's efficiency, its small size, its reasoning style, it seems like a perfect match for those specialized AI agents trained using Princeton's knowledge graph method.
So HRM could be the brain for those specialist agents.
Kind of, yeah. It could allow those agents to rapidly learn from, and, more importantly, reason over that clean symbolic knowledge from the graphs. Make deep inferences, solve complex problems within their domain, but using minimal resources.
So you get the best of both worlds, the clean knowledge and the efficient reasoning engine.
That's the potential. It's collaborative intelligence. Each part makes the other stronger, leading to an AI that's smarter, more capable, and potentially much more explainable too. It directly tackles that core challenge, giving AI both the knowledge and the thinking ability for top-tier performance.
And this is where it gets incredibly practical, right? This isn't just a theoretical nice to have. This could actually make ANDSI achievable today for way more people and organizations.
Exactly. The practicality is maybe the biggest story here.
Our source points out this combined system. It can run on standard CPUs.
No exotic hardware needed.
It uses under 200 megabytes of memory. Tiny.
Almost negligible compared to large models.
And this is the kicker. It requires less than 1% of the compute needed by something like GPT-4.
Less than 1%. That's transformative.
It really is. It's not just about performance. It's about making this kind of sophisticated reasoning power widely accessible. It's democratization.
That efficiency is a massive leap. It means advanced logical reasoning, which used to need huge data centers, huge budgets, huge energy bills.
Basically, only the tech giants could play.
Right. Now, potentially, it can run in real time, even on embedded systems. Think about devices with limited power or connectivity.
Like what kind of applications?
Consider the impact in critical fields. Healthcare diagnostics, for instance. Imagine rapid, accurate analysis running right there on a hospital's local server, maybe even a portable device. Instant insights, potentially preserving privacy by or two.
Wow. Or climate science.
Climate forecasting, yeah. Complex real-time data, huge computational needs usually. This could break bottlenecks. In these areas, the giant generalist models often struggle. They're too slow, too resource-hungry, too hard to explain.
So this combination opens doors.
It absolutely democratizes access. Startups, smaller research groups, organizations in regions with limited resources, they could suddenly tap into powerful AI reasoning that was previously out of reach. They wouldn't need the massive infrastructure or energy budget of the big guys.
It shifts the whole game. From exclusive, costly AI to something much more pervasive, specialized superintelligence becomes practical.
Enabling innovation everywhere, not just in a few well-funded labs.
So let's tie this back to the big picture. We started out talking about this shift away from the giant AGI dream towards the more pragmatic path of NDSI. How does this Princeton Sapient collaboration really cement that path, make it feel like, yes, this is how we get useful superintelligence sooner rather than later?
Well, it offers a really compelling answer to that question. Does AI superintelligence have to be a single, godlike AGI to be really impactful?
And the answer seems to be.
The answer coming from these sources is clearly no. This collaboration shows a pragmatic path toward artificial narrow-domain superintelligence, and DSI. Instead of pouring everything into the monolithic AGI dream,
Which is super hard, expensive, maybe even risky.
exactly. Instead, we focus on creating these modular networks of specialized AI agents. It just makes superintelligence feel much more achievable and, frankly, much more immediately useful for society right now.
And these agents, just to recap, they don't try to be know-it-alls.
No, they're specialists.
Trained using those Princeton Knowledge Graph curricula, so they have clean, structured expertise.
Right, a solid foundation.
Then boosted by Sapient's HRM for that fast, human-like reasoning ability.
Giving them the power to think deeply within their domain.
And crucially, they're designed to work together, to collaborate.
Precisely. This approach lets you scale up logic and reasoning across many different fields. You combine the insights from these specialized agents to tackle bigger, more complex problems compositionally.
Like that scientific review board analogy you used.
Exactly like that. Each member is a hyper-specialist. They understand their field deeply, but they can also communicate and integrate their findings with the others. You're building a collective superintelligence.
Which seems much more robust, maybe safer too.
Potentially, yes. It's arguably a more achievable, more manageable, and maybe even more ethical way to deliver the benefits of superintelligence. Focusing on tangible value through specialized expertise, it really hits the core theme of this deep dive. Making AI superintelligence practical and beneficial today.
That idea of specialized collaborative superintelligence, it really does feel like it shifts the goalposts in a productive way.
Okay, let's talk benefits. Beyond just the raw capability, what else does this approach bring?
Trust is huge, right? Especially in medicine, law, sensitive areas.
Absolutely critical.
How does this combined approach help with the black box problem? Make AI more trustworthy?
This is one of its most compelling advantages. Enhanced interpretability.
Meaning, we can understand why it does what it does.
To a much greater degree, yes. Because you start with Princeton's knowledge graphs, which have explicit structures and defined relationships.
You see the knowledge it's using.
Right. And then you add HRM, which the source says provides explicit thinking traces. You can actually follow the logical steps the AI took to reach its conclusion.
So it's not just, here's the answer. It's, here's the answer, and here's how I got there.
Exactly. You can trace the logic, see the inferences, verify the process. That kind of transparency is absolutely essential for sensitive domains. Think about accountability in medicine or fairness in legal applications.
It builds confidence.
It builds confidence and trust because you move from just accepting an AI's output to actually understanding and validating its reasoning. That's incredibly hard to get from the giant opaque generalist models.
Okay, so better performance, more trust. What about the economics? The practical side for businesses or researchers,
Huge advantages there too. As we touched on, this collaboration promises to fundamentally cut the massive costs of training and running giant models.
which have basically limited serious AI development to the biggest players.
Pretty much. But this approach maintains, according to the source, state-of-the-art accuracy across domains while slashing those costs.
So you get top performance without breaking the bank.
That's the potential. It creates this scalable, cost-effective, and transparent foundation. You can significantly improve logic and reasoning in AI models without needing supercomputer levels of resources.
What does that mean economically?
Think about the ripple effects. Lower energy consumption, which is a huge environmental and cost factor for AI now. Lower barriers for startups and university labs to innovate. The ability to deploy powerful AI in places that simply couldn't afford it before.
It makes specialized superintelligence a viable goal for almost anyone.
Exactly. It fosters wider adoption, more diverse innovation, and ultimately helps apply advanced AI where it's needed most, across many more fields and for many more people. It's about making powerful AI a tool for everyone.
So wrapping things up, we've taken quite a journey today into what feels like a really exciting and honestly very practical frontier in AI.
It definitely feels like a significant shift.
It's becoming clear that the path forward, at least for now, isn't necessarily about chasing that single, giant, all-knowing AGI with all its costs and complexities.
The focus is shifting.
Instead, the real progress, the tangible breakthroughs, seem to be coming from these specialized, highly efficient, and collaborative AI models. You've got Princeton's structured knowledge graphs providing that clean, curated expertise,
The reliable foundation.
combined with Sapient's brain-inspired super agile reasoning engine, HRM, that can handle complex logic using minimal resources.
The efficient thinking machine.
And together they create this powerful alliance, making artificial narrow-domain superintelligence ANDSI feel less like science fiction and more like a real, deployable tool for solving tough problems today.
It really does. Which leads to a final thought, perhaps, for you, the listener. If these really impactful AI advances, the ones delivering sophisticated reasoning, are now emerging from these specialized interconnected intelligences rather than those monolithic superbrains, how might that change the kinds of problems we even try to solve with AI next?
Good question.
What challenges, maybe in ultra-rare disease diagnosis or super complex legal analysis or discovering personalized drugs or modeling climate change in real time? What things that seemed impossible before now become practically solvable because we have this focused, efficient, transparent approach?
And what new doors does it open?
Exactly. And what new possibilities does this democratization of powerful reasoning unlock for society today, especially for smaller organizations or researchers or regions that maybe couldn't access this level of AI capability before? What changes when specialized superintelligence becomes a tool for many, not just a few?